discuss on statistics. So we're going to say what is this particular statistics? Statistics is a branch of mathematics that entails collection, recording, analyzing, interpretation, and presentation of data for a valid conclusion. For example, you can go to a hospital, you find the number of patients who attended but that particular day. They can record their mass. Maybe they can be 100 patients, can be 50 patients, as far as it is concerned. Now, let's have what we call the collection. For example, you've gone to a field as those patients come to that particular hospital. You can have the collection of their data. The data we need to collect maybe is can be the weight or the mass of their of these patients. So we can have a collection and then we record in a tabular form. We can have analyzing whereby we have measures of central tendencies. The measures of central tendencies where we can have mean, median, and we can have also what we call mode. So those are the measures of central tendencies. We can have also something we call interpretation. Interpretation is a process of giving the results to analyzing and a presentation of data for a valid conclusion. Maybe for the valid conclusion that we need to have, maybe the county government is the one that particular data to suggest how they're going to deliver the medicines, the number of people, like how this in that particular store, the medicines that they're going to deliver in those particular hospitals or sub-counties in that particular country. Now let's go to what we call interpretation of grouped data. The group data is, for example, that we have said, we can have exam questions, the masses of that patients in kilograms who attended the clinic are as follows. We have that age 52, 46, 14, 60, 59, 62, 73, 49, 41, 57, 58, 69, 72, 60, 58, 59. We have 79, 62, 58, 67, 54, 60, 65, 61. We have 69, 59, 70, 52, 63, 58. Those are the masses of the patients who attended that particular hospital or clinic in that particular day. The first question there says, calculate the following by use of a frequency distribution table. A frequency distribution table, that's the first question. The second one, a mean, median, variance, standard deviation. The third question, state a model class, model frequency, and model class, model frequency. Those are the questions which can be set in national exams. But now, for you to be a statistics person, you can be able to come up with your own data so that you can generate your own data. You can go to the field, collect the data, analyze, and use it for a valid conclusion. Yeah. Now when it comes to exams, for example, in KCSE or grade, you can have grade 9, grade 10. Those questions can be appeared there. So I'm going to have statistics 1 and statistics 2 concepts here. Now, when you're given this particular data, like the mass of these 30 patients, so what you do, you're going to group these masses into class boundaries. Class boundaries are going to be the range. For example, we can have the range maybe 36, maybe 52 to 60. That's the range. So I'm going to group those numbers into class boundaries. Now, the first thing you do, you come there and have the formula steps now. Rice rule. Rice rule is a formula that can be used to come up with the class boundaries of a given data. So we have two terms, cube root of the sample size n. So 2 times cube root of the sample size n. The sample size n there we have is 30. 30 is the number of patients. So you say 2 times cube root of the sample size that you're going to get 6.124. 6.124, because we are going to deal with whole numbers. We translate that 6.124 to 7, because it says that most number of classes fall between 5 to 12. Now we are going to have 7. Number 2, we can have the number of classes we have found is what? 7, by the use of Rice rule formula. Now another point that we're going to, or step we're going to take, is to find the range. Range is given the formula highest value of the minus the lowest value. When it comes to the masses of that patient who are recorded, the highest value there is 79. And then when you just look here around, we are going to search, we find what? That 8. That 8 is going to be the lowest value. So whenever you do, the range is going to be that margin, 79 minus that 8, you find 41. That is the range. Another point, we have what we call class interval or width. Is given the formula range over number of classes. So that range 41 over the number of classes which we manipulated there. So 5.86, when we change it, we going to have to all numbers, we going to have 6. We must always use all numbers. We say what? 6. Now 6 is going to be the class interval. The class interval is that margin of when you're going to arrange that over data, maybe from a certain margin. For example, we can have from that 8 to 43. So we're going to find 6. We're going to see how we can find that particular class interval. Now, because you had the number of classes, there, the first thing you must have the number of classes. We manipulate and find that it was what? 7. So you come down and draw your table. So let's just write class boundaries. You with having you said 7 number of classes. The first one 1, 2, 3, 4, 5, 6, 7. So 7, they are going to run all across that particular tables, and then we are going to have 7 number of class boundaries. The next step, you just find the midpoint. Midpoint is going to get by, for example, the first step, that 8 plus 43 divided by 2, you get 40.5. Whenever you add these class boundaries numbers and then divided by 2, you're going to get these decimal points numbers, these numbers. For example, 74 plus 79 divided by 2, 76.5. Now let's come to what we call the frequency. Frequency is how many times those numbers appear in between those class boundaries. For example, and for them, they must be included in themselves. For example, that 8 to 43. Let's go up to our data. Now let's see how many times do we have for that age, the range, the interval that 8 to 43. So you need to have 1. As you can search now, this of 41, 38 and the 41, those are 2. So you come there and you write 2 as the frequency. 2 here. Whenever you go to 44 to 49, come up to our data there. 44 to 49, we're going to have 1, 46, 2, 48, 3, 49. You come down and write 3. So now what have you realized? We have realized that the numbers even themselves from this particular range or interval 44 to 49, you're going to find that those numbers are also going to be included themselves. 44 to 49, 46, 48, and we have what? 49. 49 is also included in that particular point. So you can go and do all the vice versa. You can look for those numbers in that particular sample size, and then record their frequency as below, as we have seen in that particular table. Now we have also what we call cumulative frequency. Cumulative frequency, the first one we have 2. Now that 2, as we move down, we are going to have 2 plus 3. Cumulative frequency is calculated in this particular easiest method. 2 plus 3, 5 plus 3, 8 plus 11, 19. 19 plus 5, 24. 24 plus 5, 29. 28 plus 1, that. So the total sample size is what? 30. So that is okay. You are, now from there you can continue because the question also says that there were 30 patients. We have confirmed by the use of our cumulative frequency that sample size is what? That. Now let's go to what we call fx. Fx is good for us to find what we call the mean. F of x is going to be just you multiply these frequency times the midpoints. For example, 40.5 times 2, you get 81. 46.3, 46.5 times 3, you get 139.5. 52.5 times 3, you get 157.5. So whenever you multiply that frequency, and midpoint, you are going to get this particular data. Now, f of x, fx squared. So fx squared is just for you to have the values of the midpoints. For example, the first one, 40.5 squared times 2, you are going to get 3,280.5. For 6.5 squared times 3, you're going to get 6,486.75. So whenever you multiply this midpoint squared and the frequency, you're going to get this particular that and that in this particular column. Now, so you can add all of them and down here we record, and then you add all of them down here record. So even here, the frequency, when you add the frequencies, you're going to get that from the cumulative frequency. Here can be that. Now let's go there and start answering our questions. The question said that calculate the following by the use of a frequency distribution table. We have mean. Now, frequency distribution table, we have made it. This is our frequency distribution table. That one is 3 marks. So, and then you can come find the mean, median. Now, let's go to what we call the mean. The mean, by the formula, the sign for the mean is this one. So you say summation of fx over summation of frequency. Summation of fx 1773 over summation of f is the sample size frequencies is equals to that. Now 1773 divided by that, we get 59.1. 59.1 is going to be our mean. Now, whenever you want to find the next question there, which say the median. Now let's come to median. Median is by the formula lower class limit or boundary plus total frequency divided by 2 minus cumulative frequency times class interval over the frequency. The frequency is where that number is going to lie. For example, let's go and see we have 30 divided by 2, we get 15. So by the formula, that divided by 2, 15, you go there up, and the cumulative frequency, you see where 15 lies. So 15 lies in the class boundary of 56 to 61. Now you're going to start with the lower class limit. So you're going to use the lower class limit. From 56, we are going to have 55.5. Now you come there, you write 55.5 plus 30 divided by 2. The sample size will be 30 divided by 2, 15, minus 8. Now this 8, you're going to use it so that you subtract it before reaching that 30 divided by 2 is 15. Now, as you see these frequencies, you're going to find 8 here, and 15 lies here. 15 is in between here. And now, before reaching that 15, when you move back, the number that you see is what? 8. Now you're going to minus 8 over where that number lies. The number, which is 15, is lies between what? This frequency over 11. Now, 15 was here. We used 55.5 as the lower class limit plus, and then we said that divided by 2, 15. 15 over 2. We said that over 2 is 15 minus 8. This 8. 30 over 2 minus 8 over where the 15, that number lies, times 6. 6 now, we just got it by the class interval or width, which is here. Also can be gotten as, you can come there and say, the lower class limit, that's 7.5, and the upper class limit for 3.5. Whenever you do subtraction, you're going to get 6. Vice versa, when you also do to all these particular numbers, we can also use 74. We say 73.5 and 79.5. Whenever you minus, you're going to get this particular 6 if they ask you the question at that particular point. Now, the class width is 6. So the formula for this median is written at this particular point. This is how we write the formula for the median. So 55.5 plus 30 over 2 minus 8 over 11 times 6. So it's going to have 59.32 as our answer. Oh, let's come also to what we call the variance. The variance, you're going to have the formula summation of fx squared over summation of frequency minus summation of fx over here over summation of x over f. So you square it here. So there's a difference between this formula. Here is squared and there so brackets here and then squared, but here is not, they don't have brackets, but it's what, fx squared. Now fx squared, this is the answer for fx squared. So we write here over summation of frequency, which is what, 30 minus 1773 fx over 30, and then you square it. So variance, whenever you do it, we're going to get 80.04. And then standard deviation is going to be the square root, standard deviation square root of variance. So the square root of this variance, we are going to get 8.947. Now, what if we use what we call calculator tips? You press mod SD, you save all midpoints as the frequencies as follows. You come there, you place this one, you come to midpoints, you say you place in your calculator. You can have the calculator fx 82 ms, you place mod. Once you see SD, you place it there. You save all these midpoints. 45.5, you go to shift, you place a semicolon, you save in terms of m plus, and then you can save 46.5 shift comma m plus, you save these three, and then you can have 52.5, you go to shift, as that semicolon, it is a comment that of your calculator. So whenever you place it, bring semicolon, you place 3, you save it in terms of m plus. So you're going to see h. Whenever you're going to save these midpoints and frequencies, you're going to see that the sample size n is going to be increasing down up to when we have 30. So you can come there in your calculator and press shift, SVR, you place the first one, mean, number 1, you can see the answer is 59.1. You can also come to variance. You can go to shift SVR, and then whenever you press shift, we have got something SVR number 2. You can see the variance. This is variance. So whenever you want to find the standard deviation, just find the square root of this variance. Now we have summation of f in the calculator is going to display this particular. Whenever you want to confirm in your table, just press shift s sum. So there's a pattern there written as sum. So summation of fx squared is like fx squared. Whenever you place it, after saving all the midpoints and the frequencies, so you go to shift, there's a pattern there as sum. So you place 1, it's going to give you this one. Whenever you place 2, it's going to give you this one. And whenever you place 3, it's going to give you the sample size that. That's how we have done this. We do statistics by the use of the calculator and by the use of our manual. So those are the kind of questions which can be set in our national exams. So you're encouraged to go and do more questions, or you can suggest some of the topics that we're going to discuss ahead. Thank you for watching. Subscribe for more mathematics lessons as we go through together as a family.